As we remember, we have a hardware mechanism for defining a virtual set of instructions. Interrupts. We discussed it under the hood kernel as a set of interrupts handlers lecture. But we also have some machinery for memory virtualization at the hardware level, so-called memory management unit, MMU. Modern MMUs typically divide the virtual address space, the range of addresses used by the processor, into the pages. Each having a size which is a power of 2, usually a few kilobytes, but they may be much larger. The bottom bits of the address the offset within a page are left unchanged, but the upper address bits are the virtual page numbers. Most MMUs use an in-memory table of items called page table. Containing one page table entry per page. To map the virtual page numbers to physical physical page numbers in the main memory. The mapping does for processes, for dynamic libraries that are loaded by such a process. But actually, those are pages from physical memory to which the loaded dynamic library is shared by all processes that use it. This reduces the total amount of memory used by processes. Sometimes the PTE denies access to a virtual page, possibly because no physical RAM has been allocated for this virtual page. In this case, the MMU signals a page failure where CPU hardware interrupt, the operating system then handles this situation, perhaps trying to find a spare RAM frame to configure a new PTE to match it to the requested virtual address. If there is no free RAM, you may need to select an existing page known as a victim using some replacement algorithm and save it to disk. A process called paging or swapping. When the process scheduler tries to resume the replaced process on the CPU, pages swapped out to the disk again will be reloaded from disk to memory by a page fault interrupt. Also, the MMU may generate illegal access error conditions or invalid page faults upon illegal or non-existing memory accesses, respectively leading to segmentation fault or bus error conditions when handled by the operating system. In this case, the operating system can create a core dump with a memory image of the process for further debugging and crash analysis. More information you can find in our Under the Hood lecture about the core dumps.